Hello, Class H. Let's take your quiz, or excuse me, your test. Um, so we've got a piecewise function here, and we've got a parabola on two ends and a line in between them. And what we want to have happen at 1 and 3 is for the parabola to connect to the line, then to connect to the other parabola. And so we know that parabolas and lines are continuous everywhere, but we don't know in this case how to make it connect at 1 and 3. So let's take a look at the limit as x approaches 1 from the left. That would be this equation right there. So I'm just going to write f of x instead of write it all out, and I get 1 plus b plus c. And I want that limit to equal the limit as x approaches 1 from the right. And again, that would be these values right here. So that would actually be 5 minus 9, which is negative 4. So that gives me my first system of equation, or first equation in a system. 1 plus b plus c equals negative 4. So I'm going to bank b plus c equals negative 5. And let's go get the other equation that's going to come from putting the line and the parabola together at x equals 3. So we're going to take a limit as x approaches 3 from the left of f of x. And when I plug in 3 from the left, that would be less than 3. Then 15 minus 9 is 6. And we want that limit to equal the limit as x approaches 3 from the right, back into the parabola on bottom. And I get 9 plus 3b plus c. And so for those to equal, let's see, I will get 3b plus c equals, when I subtract the 9, I'll get negative 3. I like to add instead of subtract, so I'm going to change all the signs. Negative 3b minus c equals positive 3. And when I add those, I get negative 2b equals negative 2, and b equals negative 1. Plugging back into any one of the equations, if I go up here, if b is negative 1 plus c equals negative 5, c then is going to equal negative 4. And why did I think this answer was, there's my problem. B is positive 1. So I get a 1 there, and I get a negative 6. That's better. Okay, so B is 1 and C is negative 6. So I'm just going to go up here and rewrite my function now that I know what B and C are. I get x squared plus x minus 6 for x less than or equal to 1. The line doesn't change, 5x minus 9 for values of x between 1 and 3. And then again, x squared plus x minus 6 for values of x greater than or equal to 3. So in B, I want to evaluate the limit as x approaches 2. And so I go up here, and 2 is on this interval, and it's going to be from the left and right of 2. So that's going to equal 5 times 2 minus 9. 10 minus 9 is 1. Again, if you got different values for B and C up above, it really shouldn't even matter because 5x minus 9 was given. So I just wanted to see that you knew which piece of the piecewise function to take that limit. All right, now let's do the limit as x approaches 3. And this is kind of weird because you've got really two different functions as x approaches 3, but they approach the same thing. Remember, we made them continuous, so I should be able to use either one and get the same answer. So let's see. Notice that x is approaching 3. It's not from the left, it's not from the right, it's from both sides. So I'm just going to put the 5x minus 9 up there. Again, you will get the very same answer if you put the parabola up there. Okay, and this is a limit as x approaches 3. So when I plug 3 in, 15 minus 9 is 6. And 3 minus 3 is 0. And what does that mean? I mean, let's think about this. This is a rational expression. x minus 3 is in the denominator. There's an asymptote at x minus 3. And I don't know, I could look it from the left and look it from the right, but from one direction it's going to positive infinity, and the other direction of 3 it's going to negative infinity. So this limit does not exist because you're approaching an asymptote from both sides. D wants to make f differentiable at x equals 1. And so what I want to do here is take a piecewise derivative. So the derivative of my parabola part is 2x plus 1, and in the middle is 5. So f prime of x is 2x plus 1, 5, and 2x plus 1. This would be x, make sure I get my numbers right, less than 1, between 1 and 3. I really don't even need the last part of it because I'm just looking at if it's differentiable at 1, but I'm going to go ahead and finish it up, x greater than 3. So is it differentiable at x equals 1? If I take a limit of the derivative of 1 from the left of 2x plus 1, I get 3. And the limit as x approaches 1 from the right of 5 is just 5. And these two do not equal. So they are not meeting up in a smooth curve, and so we would say, therefore, not differentiable. On a piecewise function, you're looking to see if the derivative from the left and the derivative from the right are the same, and in this case, they're not. For those of you who looked at this and didn't know what to do, I just don't know what to say. This is definition of the derivative. Straight up, you define the function. So this right here is your f of x plus change of x minus f of x. And notice because there's more than two terms, there's a minus the quantity here. Some of you missed the sign and you went with the plus, but really the function is minus because this is minus a negative x to the 2/3. So f of x is 5 sine of x, and then minus x to the 2/3. This is the definition of the derivative. And so you go, oh, all I have to do is take the derivative, which is 5 cosine of x, minus 2/3, x to the negative 1/3. And we have gotten through the first page. Let's look at the second page. I think we can get all this in here. We've got a cup of tea placed on the counter left to cool. And we have random temperature readings at certain minutes. 0, it's starting off at 180, and then it cools after 2 minutes to 174, 172, and so on. I think it's safe to say this is a continuous function, that you don't jump over a temperature when you're cooling. It doesn't go right from 180 to 162 without passing every degree possible in between. So, using the data in the table, so I don't want you making stuff up, just what I give you, find the average rate of change from 0 to 9. So that would be change in temperature over change in time. I hate that I used x for this, but I did just because I didn't want a capital T and a little t. So our change in t, 162 minus 180 over 9 minus 0 gives us negative 18 over 9, which is negative 2. Include units, and that would be degrees per minute. Some of you put degrees Fahrenheit, and that's fine. So there's our average rate of change. Again, using the times listed in the table, the shortest time interval during which there must exist a time for which the temperature of the tea is 166.5. And I'm looking at these two times right there at 5 and 8 minutes. So first of all, t of x is a continuous function. We are acknowledging the fact that you cannot just hop over certain degrees. You go from one to the next. It's a continuous function, or what's happening here is continuous. So by the intermediate value theorem, since t of 8, which is 164, so I would let you use either t of 8 or 164, is less than 166.5. Likewise, t of 5 is greater than 166.5, and that temperature is 168. Then there exists a time over the interval 5 to 8 where t of x equals 166.5. Use the data in the table. Again, don't make stuff up, just what I give you, to find the best estimate of the instantaneous rate of change. Instantaneous rate of change, another word for that would be derivative. So I'm going to go here to t equals 4. I'm going to look to the left, and that change in temperature is 1. I'm going to look to the right, and that change of temperature is 2. What's the smallest? It would be 1. So t prime of 4 is approximately equal to 168 minus 172 over 5 minus 4. And did I get that right? I don't think I did. 168. Yeah, -4. I didn't ask for units there, so I didn't look for them. So -4. So that is my best estimate. Why is it my best estimate? Because delta x is approaching 0. That's the closest. And you may say, but I said something like that. And I know a lot of you did. I know a lot of you understood what was going on here. But we're talking about a derivative. So let's go back to the definition of the derivative. The best estimate for the instantaneous rate of change is going to be where the change of x is closest to 0. And then here we start doing something that is a lot more straightforward. And so hopefully we had a lot of success here. We need the equation of a tangent line at x equals 2. For an equation of a tangent line, I need a point and a slope. So we've got the x value. Plugging in the original, I find that the y value is 1. So I can go ahead and set this up. Y minus 1 equals the slope times x minus 2, and let's go find our slope. First thing to do is take the derivative. So 4 times the quantity x squared minus 3 cubed times 2x, the ever important chain rule. Plugging in 2 here, we get 4 times 4, which is 16, and we plop that in there, and we finished the first part of that question. Values of x for which the graph of f has a horizontal tangent. So we're asking ourselves, where is the slope of the tangent equal to 0? So I'm going to take my derivative. And in the future, I really want you to see you set that derivative equal to 0 and not just pull values out. I know that because I had already given it to you all nice and factored, those of you that expanded it spent a lot of time that you didn't need to, because x equals 0, x squared equals 3, so x equals plus or minus √3. So over the whole domain of this question, the horizontal tangents are at 0 and plus or minus 3. And now let's take a second derivative. So I'm going to look at this, bring it down. Here's the first derivative. I'm going to have to chain rule again because of this. And the 8x times the parenthesis is implying product rule. So here we go. 1 d2, so 3 times the quantity x squared minus 3 squared times 2x. So there's that chain rule happening again, plus 2 d1, and I get the heck out of Dodge because I have finished the second derivative and I'm not cleaning it up for anybody. And here's the problem that I let be the bonus. The reason I wanted you to include a sketch was because I thought maybe it would help you see what you were doing. And for some of you, I think it did. So there's a kind of a rough sketch of x squared. Bring this down a little bit. Here's the point 1. negative 3. 1, negative 3 is clearly not on the graph, but I think that I can see that I'm going to have a tangent there and possibly one here. But I have no clue what those values of x are. I do know that the slope of those tangents have to, whatever value of x, the slopes are going to be 2 times x. I also know that the slope of this line from 1, negative 3 to any point on here is x comma f of x. And I might as well go ahead and put in f of x or y is x squared. So I'm going to set the derivative equal to good old-fashioned slope. So x squared plus 3, y2 minus y1 over x2 minus x1. And I'm going to cross multiply. And get x squared minus 2x minus 3. This factors beautifully, x minus 3, x plus 1, which makes it so much easier than the one that was on the homework like this. And so our x's are 3 and negative 1. The corresponding y's, if you want to go that route, are 9 and 1. Some of you did point slope with the point that was given, and that's perfectly fine. If I use the 2 points here and here, that's fine too. You're going to get equivalent equations of lines. Here my slope is 6, 3 times 2, and here my slope is negative 2. So you can see just quickly y minus 9 equals 6 times x minus 3. Likewise, y minus 1 equals negative 2 times x plus 1. And let's take a look at the chart problem with, here we have quotient rule. Here we have chain rule, and it looks like grr. Let's try that again, chain rule, and this is the square root of f of x. Again, kind of when you say of, that's a clear reason for needing to use the chain rule. So quotient rule, here we go. Let's do it in terms of x first. We always do it in terms of x and then put our value in. So low, d high, minus high, d low, over the square of what's below. So we're going to do this in terms of 2. So h prime of 2 is, so I'm looking here on this column with the 2's. I know it gets kind of confusing. We have negative 3 times negative 2 minus 5 times 1. 6 minus 5 is 1, and f of 2 is negative 3, squared is 9. So the answer to A was 1/9. Again, if you left things messy, then it looked like this, but it was equivalent to my answer. So that's perfectly fine. Here our j prime of x is f prime of g of x times g prime of x. So j prime of 2 is f prime of g of 2, but g of 2 is 5. So I'm going to put that in there. And then times g prime of 5 is 2. F prime of 5 is, what, 7? Why did I think this answer was? It's negative 2. I knew the answer was negative 14. 7 times negative 2 equals negative 14. And haha, some of you left it like that, and you got full credit. All right, here, let's rewrite k of x. K of x is actually f of x raised to the 1/2 power. So k prime of x is 1/2 f of x to the negative 1/2 chain rule times f prime of x. So we have 1/2 f of 5 is 4 to the negative 1/2 times f prime of 5, which is 7. And you have a 1/2 times a 1/2 times a 7, and the answer was 7/4. Okay, I was really pleased overall with our implicit differentiation. Everything that we did at the end seemed to go really well. So let's walk through this. 9y squared dy. This is product rule. So 1 is negative 2x dy plus y. And so the derivative of negative 2x is negative 2 dx plus 2x dx. And the derivative of a constant is 0. Dividing through by dx. And having lovely 2 dy dx terms right there at the beginning to factor out. 9y squared minus 2x. Taking the 2y over and subtracting the 2x. And then our final answer is 2y minus 2x divided by 9y squared minus 2x. Last question. So, given a function where f is differentiable for all values of x. So I'm not worried about f, but where am I not differentiable for cotangent of x? Let's look at cotangent of x and talk about continuity. Cotangent is cosine of x over sine. So over this interval, where is sine x equal to 0? And that would be at x equals pi. Justify your answer, because at x equals pi, g is not continuous. Is it differentiable? Well, we're going to have to take the derivative somewhere for a and b, so let's go ahead and do that. G prime of x is 1 d2 plus 2 d1. I put a prime there, sorry, and f prime of x, okay? I've already handled the cotangent of x up above. Cosecant is 1 over sine squared, so we would still be dealing with pi. We don't have any new denominators. We just have sine, so we're going to call it good. Here's our answer. G is not continuous, therefore not differentiable. And we've taken the derivative and seen that we didn't lose any other values of x. We've already got g prime, so let's finish this up. F of pi fourths negative cosecant squared of pi fourths plus cotangent of pi fourths times f prime of pi fourths. So f of pi fourths is 4. Sine of pi fourths is 1 over root 2, so cosecant is going to be root 2 over 1. We're going to square it and make it negative outside. We're not squaring the negative. Cotangent of pi fourths is 1, and f prime is negative 2. So I have 4 times 2 minus 2 is 8 minus 2 is 6. I hope this helps. If you still have questions, please come and see me next week, and have a great weekend. Bye.